right? So you continue. Therefore, your equation will be Fn is Fn minus 1 plus Fn minus 2 plus Fn minus 3 plus F1 plus 2n minus 4. And that comes from this. Okay, does that answer your question? And if you want to validate, you can validate this. So you can say F1 is 0, F2 is 0, F3 is 1. So F4 is 2n minus 4 plus F3 plus F2 plus F1. N is 4, so this 4 minus 4 is 0, so that becomes 2 power of 0 plus F3, and the rest will be 0, so this gives you 2. So far so good. And F5 is 2n minus 4 plus F4 plus F3. N is 5, so this will be 2 power 1 plus 1 plus 1, actually plus 2 plus 1. 2 plus 2 plus 1 will be 5. So that matches. F6 is 2 power 2 plus 5 plus 2 plus 1 will be 4 plus 5 plus 2 plus 1 will be 12. And that matches again. Just as a way to check. Yes?
In the exam, do we need to find a closed form for this?
You don't have to find a closed form. I'm pretty sure we said that in the exam, didn't we? Do we say you don't need closed form?
Yeah.
Which page? Do you say we don't need closed form?
Yeah.
Okay. All right. Yeah, you don't need to. You don't need to write a closed form. Okay. Any other questions? Yes.
Can you explain why f of 1 and f of 2 are 0?
When partition 1, how many times you use 3?
In partition f of n minus 1, 2, 3.
Okay, let me repeat your question. Why is F1 0?
Yeah, that's what I asked.
F1 means you partition 1. And F means how many times you use 3? Can you use 3 when you partition 1? No. Right. Okay. Can you use 3 when you partition 2? No. Because if you use 3, the next number will be minus 1. And we don't want negative numbers. Okay. Any other questions? Yes, please.
So, if instead of 3 it was 4, would you have 2n minus 5?
Yeah.
So that's, okay.
Okay. So if you use 4, then this number, you're counting how many lines you have here. Right. Okay. Any other questions? Yes.
How do you calculate the total number you used?
The total number of the what?
You used in the partition.
I don't understand you. How do I calculate what?
The total numbers. The total number.
How many numbers you use?
Yeah.
Okay. Okay, so your question is, let me try to understand your question. Your question is, if I have, let's say 3 equal to 1 plus 1 plus 1 equal to 1 plus 2, you want to count 1, 2, 3,
Yeah.
4, 5, 6, 7, 8. Is that right? Okay. So the question is, how many numbers are used? Is that your question?
Yes.
So F1 is 1. When you partition 1, you use only one number. F2 is 3. Why? Because 1 plus 1 and 2, you use 3 numbers. Okay? Now n equal to 1 plus n minus 1. Actually, there are many lines here, right? And 2 plus n minus 2, there are also many lines here. And 3 plus n minus 3, and so on. Okay? So let's consider this case. How many lines are there? When we partition n and the first number is 1, how many lines are there? 2 power n minus 2. Because we have proven when you partition n, you have 2 power n minus 1 lines. When we partition n minus 1, we have 2 power n minus 2 lines. Is everybody following me? Okay, so if Fn, so how many numbers are used for the first number? Just look at the first number is 1. How many times I need to use? How many numbers have I added into? Yes?
2 to the power of n minus 2.
2 power n minus 2 because I only count these numbers, right? There are so many lines. So I have added so many numbers. How many numbers do I need to partition? Do I use to partition n minus 1? I don't know. I just put n minus 1 back. So this means how many numbers am I using when I partition n and the first number is 1? This count how many times I use 1. This count how many numbers I use for the rest. Are you with me? Make sense so far? Now I count the second situation. The first number is 2. How many times I need use 2?
N minus 3.
2n minus 3. That's so many times I use 2 for the first number because there are so many lines. How many numbers do I use for n minus 2? So this part is how many numbers do I use when I partition n and the first number is 2. I use 2 so many times. I use so many numbers for the rest. You agree with me? Are you good? Okay. And then for the number is 3. And then finally you have n minus 1 plus 1 and then n. So n minus 1 will be 2 n minus, I should say n minus 1 minus n. This will be 1, right? So this will be 2, 1 minus 1 plus f1, and this will be plus 1. So you add them together. This means that, and this means this. And finally 1, it means that. Did I answer your question?
Yeah.
Okay?
What is the 2, 1 minus 1?
Which one?
The 2 to the power
This one?
of 0? Yeah.
Oh, because I continue our equation. For the first, this one, look at this. This n minus 1, right? This corresponds to n minus 2. So this 1 so corresponds to 1 minus 1. So means you use only one number for n minus 1.
Okay.
Does that answer your question?
Yeah.
Okay. Any other question? Yes, please.
It is the exam 3,
Which semester?
fall 2013,
Fall 2013.
question 1.
Exam 3. You say exam 3?
Yeah, exam 3.
Okay, exam 3. question number 1?
Yeah.
Okay. So ASCII use 8-bit to store. Let me change to laptop. To store characters, this is inefficient if only decimal digits are used. For storing 1 decimal digit, only 4 bits are necessary. This question asks you to implement a structure called DECPACK, means packing decimal numbers, because it packs 2 decimal digits into 1 byte, unsigned char. Each DECPACK object has 3 attributes. The size means the maximum number of decimal digits that can be stored in a DECPACK object. Use means the actual number of decimal digits that is stored in a DECPACK object. Data is an array of unsigned characters. Each element stores 2 decimal digits. The upper or the left 4 bits store 1 decimal digit, and the lower right 4 bits store another decimal digit. If an attribute size is an even number, the size of the array should be size divided by 2, because you can store 2 decimal digits for each element. Right? If the size is an odd number, then you should add 1. So if you want to store 3 decimal digits, you need 2 bytes. You need to add 1 and divide by 2. If 3 divided by 2 becomes 1, so you don't have space for the last one. Any questions so far? Does everybody understand what we try to do? Okay, when inserting a decimal digit using insert, the function checks whether the data is full. If it is full, the size of the array doubles. The old array is copied to the new array, and the memory for the old array is released. If a byte has not been used, the decimal digit is going to use the upper 4 bits. If upper 4 bits of a byte is already used, the decimal digit uses the lower 4 bits. When deleting a decimal digit, using the delete function, modify used and return the most recently inserted decimal digit. The digit value must be between 0 and 9, not ASCII 0 and 9, because ASCII 0 will actually be 48, right? I don't remember. I think it's 48, but I don't remember. Delete function does not string the data array, even if you don't use anything there. Every time you delete, you decrement the size, but you don't string the array to make things easier. The print function prints the decimal digit stored in the object. The printed decimal digit should be between 0 and 9, because if you print 0, the value 0 is not visible. You have to print the ASCII value 0. If the value is 0, you actually print the character 0. The function does not print invisible character. Finally, destroy or release the memory. Okay, any questions about what needs to be done? Okay, do you have a specific question, or you want me to go through the whole question?
My questions start on. Well, I mean, it might be easier if you go through all of it since it builds on it, but I mean, my questions start on the third part.
That's fine. So first, we define the structure for you. What size used and unsigned character to store a digit. So the create function will create. Oh, I didn't mark it here. The create function will create an object. SC is the maximum size of the number we can store. So first is to allocate memory for DECPACK. It's a multiple choice question. Which one should we choose? Should we choose number 1? A? No, why not?
Because there's more parts to that pack.
It's not integer, right? You have to make sure the left side and the right side match. How about number 2? No, it's not integer. The type is DECPACK. How about number 3? The right side is dead pack. Is it good? Why not? dp the pointer. You have to put asterisk in front of dp. Okay, how about number 4? Okay, so the answer for this question is number 4. Okay? So check whether allocation fails. Initialize size to and use to 0. Allocate memory for data. Each element can store 2 digits. I think I say the same thing twice. Allocate enough memory, no more than necessary. So how much memory should we allocate? Should we do A? Should we do A? No, why not?
Because you have to because you're putting 2 decimal numbers in each one, so you definitely need to have about
You
half
need
the
to divide by 2,
number. Divide by 2.
right? Should we do number 2, B? No, because it's not dependent on your size, right? Should we do number C? No, because the type don't match. Data is unsigned character, and right side you use that pack. So we left D and E. Should we do D or E?
E.
E, because we need to increment, not decrement, right? So if your size, you want to store 5 digits, you use 3 bytes, not 2, right? So you need to increment. So the number is E. You agree? Agree? Okay. So check whether allocation fails. All right. And now the next is insert function. Insert decimal digit into the object. The new digit is at the end of the sequence. You can assume the number is between 0 and 9. So first, if we don't have an object, we don't do anything. Second, if the value is not 0 and 9, between 0 and 9, we don't do anything. Then if the allocated memory is full, double the size, and allocated memory, copy the data, release the old memory, and insert a new digit. So first, we say used is how much we have used, right? And used equal to size means we have used up all the space we have allocated. Therefore, we need to double the size. Allocate enough memory and no more than necessary. Each element of data can store 2 digits. So we are going to allocate new data. Now look at this. So we have A, B, C, D. Look at A. Is A good? Let me show you B, C, and D, E. So we need to, let me go back to it here. Allocate memory for double size. I'm reading the comment. Allocate enough memory, no more than necessary. Each element of data can store 2 digits. So first question is how much memory should you allocate? Second is how much should you copy? Okay, let's first look at B. Is B correct? We allocate the memory, we copy, release memory, and let me not go to B first. Let me go to C first. I'm eliminating incorrect answers. Is C correct? Why not? There's new value in new data. What does that mean?
I'm not putting anything inside new data.
You are not copying the data. So you store away the old data. Right, look at C. We allocate memory, then we release all the memory. We have not copied, so we throw away the old data. So C is wrong. Does that make sense? You are not copying the data. How about D? Is D right? Same problem. We are not copying the old data. We throw away the old data. You actually have a memory leak. So D is not right. How about, where's my cursor? How about E? Who say no? You free the data before you you copy the data, right? So when you line 136 release the data and 139 want to use the data, so E is incorrect. So C, D, E all of them are incorrect. Now let's go back to A and B. So if you look at A and B, see what I can put in. I need to zoom out a little bit. Okay, I think the screen is okay. What's the difference between A and B?
You double the size in
You double the size in A. So which one is correct? A. What's wrong with B? You are not changing the size. Right? So B is incorrect. Yes?
Why don't you have to double the size before you malloc the new data?
Do you double the size before you malloc or you double the size after you malloc?
Well, I don't understand why you don't do it before. That's my question.
Okay. So the question is, should we double the size before malloc or should we double the size after malloc? When your size is 6, how many bytes do you allocate?
Didn't it say if they were all filled up to double it?
Yes, but when the size is 6, what does that mean? You can accommodate 6 decimal digits, right? How many bytes do you need? 3. Because each byte accommodates 2 digits. Therefore, if you allocate with size in line 90, you redouble your array. Now go back to the create function.
But isn't that assuming that half of it is already empty?
Remember, we have divide by 2 here. We don't allocate more than necessary, right? So if your size is 6, you allocate 3 bytes. You need 7 digits, you allocate 4 bytes. So this is already tight. You divide by 2 here, and then later on you double the size, you allocate without by 2, then you double the size. Does that make sense?
Yeah, so by not doing anything, you're doubling the size.
Correct.
Yeah.
If you don't divide by 2, you are already doubling the array. Does that make sense?
Yeah.
Okay.
Could you explain the for loop?
Okay, so then the for loop will go through. We'll go through the list. I think this should be +1 here, because you may skip the last one. This copying the old data to the new data, the new array.
Why do we do iter by 2?
Excuse me?
Why do we do new data of iter by 2?
Oh, because you have so many elements. Let's say you have 5 elements. How many arrays? If you use is 5.
Yeah.
How many bytes are you using?
You had 3, so
3.
yeah.
Yeah. Actually, this should have +1 there. I'm sorry about that.
Wait, so I don't get it. If you have 3, then
If you use
can't you just run the loop until used by 2 times and then just say new data of iter?
say that again. Can you
If
use?
you run the loop half number of times, will it be the same thing?
Yes. You can do divide by 2 here. Yeah. Okay.
I still don't understand the TP size multiplied by 2.
You mean this one?
Yeah, because I don't see we use that later on the code?
Well, you need to know the size before you can put anything to the array, right? If you use up all the elements in the array, then the next one you don't want to insert has no size, no space. Right? You have an array of a size, some size. You want to keep inserting data into your array. Eventually, you'll run out of space in the array. When you run out of space in the array, you are going to double the array. But you don't want to store away the old data. That's the reason you have to copy it. Does that make sense?
No.
No? You have an array of a size. You keep inserting data into the array. Eventually, you are going to run out of space in the array.
I just don't see where we use the double size.
Double size, what do you mean? Which? Well,
So-
you use it here. That line says whether you have used up your space. And if you use up your space, you have to increase your space. Since you checked over here, later on you don't have to check. You already checked,
Okay.
right? Actually, I think the use plus one is handled the next. So after we checked, when we come up here, we have already checked. So when we come up here, we know we have enough space. Right? Because if we run out of space, that's already handled. Does that make sense? Does that make sense? So when we come up to this point, we have space. Now, we have to see what's used, right? If used is an even number, let's say use is 0. I have not used anything. Should I use on the upper 4 bits or lower 4 bits? So each byte has 2 decimal numbers. If used is 0, that means I'm going to use the first byte. Am I using the upper 4 bits or lower 4 bits?
Lower.
Lower? Someone else?
Upper.
Upper? Okay. Why do you say lower?
Still empty.
Still empty, and why do you say upper?
And when we define the structure, we said that we fill the upper 4 bits first.
Okay, so we said that, right? If a byte has not been used, the decimal digit used the upper 4 bits. Okay, so that's the definition of it. Okay. So we use upper 4 bits. So if used is an even number, if used is 2, what does that mean? It means we have used the first byte. Right? We have used the first byte. And we want to use the next byte. So if used is even, we want to use the upper 4 bits. You seem puzzled.
No, I just can't see.
Okay. If used is an even number, means we have occupied some bytes completely. Do you agree with me? If used is 0, means we have not occupied any byte. If used is 2, means we occupy the first byte completely. If used is 4, that means we have occupied 2 bytes completely. Does that make sense? So if used is 4, that means we use 2 bytes. So the next thing I'm going to use is going to be the upper 4 bits of the third byte. Do you agree with me? Are you following? Okay. Now I need to calculate index. If use is 0, obviously I use the element as 0. If use is 2, which So this will be index 1, this will be, index 0, index 1, index 2. If use is 2, which one do I use? Index 1. Do you agree with me? If use is 4, that means I have used 2 bytes completely, and the next one I use is index 2. So the index is going to be used divided by 2. You still seem still puzzled.
I'm trying to see which option looks right and I can't see it, so I squint at it.
Okay. Are you good now? Yes.
So if it's 2, then that means everything you do from here on is going to be index 1, that's 0 still.
Is what?
So if you use 2,
If use is 2, yes.
then 0 is already filled up, so you're just using 1.
Yes, so the index will be 1. Because index 0 has each index corresponds to 2 decimal digits. Right? So if use is 2, means I have used 2 digits. And that means I have used up the space for index 0. Does that make sense?
Yeah.
So the index is used divided by 2. Therefore, we can eliminate A and E. Right? The index is wrong. For A and E, the index is wrong. Now we need to use alpha 4 bits. So which one, B, C, D, which one does it give us alpha 4 bits? If the number is, let's say, 5, if a number is 5, how do I store 5? 5 corresponds to 0, 1, 0, 1. What would the byte look like? Let's say I'm using this. How do I get? I want to get 0, 1, 0, 1 here. Do you agree? That's what it says. The definition says I want to use upper 4 bits. How do I get there? What's the answer? Yes.
The worst value's initial position. We're thinking it 4 one way or the other.
What's your question?
And like what is value's initial position?
What's
We're
various
thinking
initial
it
position?
4 left or right, so I don't know which way.
It says line 69. You can assume value is between 0 and 9. And we actually checked in line 76. We actually check value is between 0 and 9. Because if it's not between 0 and 9, this function quit. So how do I move a number to the alpha 4 bits? Want to try?
I mean, wait, you're still looking at the first one, right?
Excuse me?
Are we still looking at the even case?
We look at the question number 4. Question number 4 here.
Well, so the arrows are the bit shifting operators.
Yes,
So
that will be
then B.
B. You need to shift left by 4 bits.
Is that just because you want the index to start on the upper one?
Yes, so we already explained. Is your question about why do we divide by 2?
No, my question is, is value automatically pointing to the lower bits? And that's why we
The
have to
value
move it
is
up to
between
upper?
0 and 9. Because we already checked. And 0 and 9 will occupy the lower 4 bits. 0 means 0, 0, 0, 0. And of course, upper will be 0. Right? The biggest number is 9. But the 9 means you have only F, this will be 0. That's how you get 9. Right? Does that make sense?
Yeah.
So when you have a number 9, you use at most 4 bits in the lower part. You have to shift left by 4 bits to get there. If your number is 5, you have to move 5 over here. That's the reason the answer is B. Okay?
What?
Yes.
What does the bit shift do there?
Which one?
The value, the bit shift operator.
That means you add, if you shift left, this means shift left. That means you add 4 zeros on the right side. If you have a vowel is 5, that means 0, 1, 0, 1. And vowel shift left means 0, 1, 0, 1. You add 4 zeros here.
Okay.
Okay?
So
Does
now
that answer your question?
now it's 8 bits instead of 4.
Well, it's always 8 bit because we use 1 byte,
Right.
right? Each element in data is 1 byte. Yes?
What does constant D and E actually do on the right?
Okay, D and E are the mask. This means bitwise AND. And if you want to, actually we have this in the handout. We have bitwise operation. I think I mentioned it here. Maybe earlier. Somewhere in the handout I mentioned the bitwise operation, but here I'm going to explain that to you. If you have, let's say number A is 0, 1, 1, 0, 1, 1, 0, 1. B is 1, 0, 1, 0, 1, 0, 0, 1. If you do a bitwise AND operation, then you get 0, 0, 1, 0. If both bits are 1, you get 1. Otherwise, you get 0. That's the definition of bitwise operation. Bitwise OR operation, there's only 1 bar here. That means if either is 1, you get 1. If both 0, you get 0. That's bitwise OR operation. This is bitwise AND operation.
What is X and F?
What?
The X and the F.
Yeah, what is
OX means it's hexadecimal. That means I use ABC 0 to 9 and A, B, C, D, E, F. They correspond to, so this will be hexadecimal, this will be decimal. This will correspond to decimal 10, 11, 12, 13, 14, and 15. Hexadecimal means it's base 16. Not decimal means it's base 10. Since 16 is the power of 2, it's easier to represent bits using hexadecimal. So F corresponds to 1111 in binary. This corresponds to 1110 in binary. Okay, any more questions? Yes?
So D would keep the left part of the backpack, but then
D will keep, yes, D will keep the left part of the left hand.
and then delete the right part will just be zeros.
And yes, D will delete the right 4 bits. because you use bitwise AND, and since you have 0 there and it's decimal. Decimal means each symbol means 4 bits. So D will actually always be 0 because your vowel is between 0 and 9. So it's always less than 16, right? Vowel is always less than 16. If you do bitwise OR, then vowel is use at most 4 bits. It's between 0 and 9, so you use at most 4 bits. If you do AND with F0, so you will eliminate the 4 bits because you use 0 there. The vowel is between 0 to 9, so you have at most 4 bits. Because 9 is 1, 0, 0, 1, you use at most 4 bits. If you do bitwise AND with hexadecimal, F0. F0 in bit representation is 1, 1, 1, 1, 0, 0, 0, 0. That's your bit representation. So if you do vowel AND hexadecimal, F0, that means at the most, you don't have anything up. At the most, you have 0. The biggest number is 9. And this one will be 1, 1, 1, 1, 0, 0, 0, 0. So if you do an AND, this will be 0, this will be 0. So that always gives you 0. So what number D does is you always get 0. What's wrong with number E? E is wrong for 2 reasons. First, you have wrong index. You should use divide by 2. Second, you are using the lower 4 bits, not the upper 4 bits. So that's why E is wrong.
Can you go back to that sheet for a second?
Sure.
Thank you.
Then what is OF? OF in the E, choice E.
OF? You mean
OX,
OXF?
OX, OF.
0F.
Okay.
It's 0F. Not O, it's 0.
Okay. So what does it represent? I still don't get the part.
0F, 0, you mean this? Or you mean this?
0 is F0 is 0, 0, 0. Then what is 0F?
0F is hexadecimal. That means 0, 0, 0, 0, 1, 1, 1, 1. This hexadecimal means this is bit. This means hexadecimal. This means bit. 0, each one corresponds to 4 bits because hexadecimal is 16. 16 is 16 base 16, and 16 is 2 power 4. Therefore, each one corresponds to 4 bits. So 0F means in bit representations 4 zeros followed by 4 ones. If you start with 0x at the beginning, means it is hexadecimal. Does that answer your question?
Yes.
Okay.
But
Yes?
So we're supposed to know that F in hexadecimal is 1111.
Yes. And if you didn't know, now you do.
Okay. And then we should know all the other characters too.
Yes, A, B, C, D, E, F. A corresponds to 1110. A corresponds to, so it's 0 to 9, then A, B, C, D, E, F.
How does that correspond to 0 to 9?
Okay,
What is the X?
excuse me?
What is the X?
What is what?
What is X.
X. This means the next one is it start with hex. It means it represents hexadecimal.
Okay.
And 0 to 9, I assume you know you are familiar with that. The next one will be A. So this will be hexadecimal, this will be decimal, this corresponds to 10, and binary, this corresponds to 1010. Why? Because 9 is 1001. This will be 2 power of 0, this will be 2 power of 1, 2 power of 2, 2 power of 3. So this one corresponds to 2 power of 3 plus 2 power of 1 equal to 10. So A, B, C, D, E, F correspond to decimal 11, 11, 12, 13, 14, 15. And decimal means 1011. Yes?
What's the difference between using the capital X and the lowercase x in the 0x followed by the x decimal?
You just need to be consistent. Uppercase, lowercase. If you use uppercase X, you need to use uppercase A, B, C, D, E, F. If you use lowercase, you lowercase both. Okay, should we go on? Are we done with this question? Okay, so for those people that are taking notes, I'm going to scroll down, then I will change. Okay, so if you are using, if use is R number, if you are still taking notes, if used is R, what does that mean? Let's say consider used is 7. What does that mean? And each byte can accommodate 2 digits. Therefore, which index should I use? Which index should I use? 3. 7 means you have used 1, 2, 3, 4, 5, 6, 7. So the index will be how do you get 3 from use? 7 minus 1 divided by 2, or you simply say use divided by 2. Why? Because it's integer division, you solve a remainder. Okay, so index is used divided by 2. Therefore, if you look at the answer A, B, C, D, E, you know A and E, A and D are already wrong. Your index is wrong. Right? So A and D are wrong. Your index is wrong. Now, if you use is an R number, how do you put that number in? You need to put it in the lower 4 bits. Well, that's by definition. You need to put in the lower 4 bits. So we are going to take the upper 4 bits and add the new number. So would that be number B? What does B mean? Add the value add something to your array element. What's the right hand side? What's the right hand side? What? The lower bit. But val shift right by 4, what does that mean? What's val? Between 0 to 9. You shift right by 4, it becomes 0. So B means you always add 0. Right? Val is between 0 and 9. If you shift right by 4, so val has use only 4 bits. So val shift right by 4 means you take the 4 bits, shift right, and add 4 more bits here, add 4 more 0 here. That's shift right by 4 means. Since val use only 4 bits, these are always 0. The upper 4 bits are always 0. Therefore, val shift right is always 0. Yes?
When you shift the 4 bits, do they like just disappear or?
They disappear, they get thrown away.
So they just
Yes. In some language, they have something called shift rotate. C does not. So they just get thrown away. Because you can do shift rotate using other things. You don't have to have that operation. So they just get thrown away. Therefore, B, the right side of a B is always 0. That's not what you want. Right? How about E? Is E correct? Why?
Because one would just add zeros to the.
Because you want the lower 4 bits. Use is R number, you want to, the new number has to occupy lower 4 bits. And E, you make lower 4 bits 0, so you are not doing the right thing. So we get rid of A, B, D, and E. Right, the only answer will be C. What does C mean? C means, so you get a correct index, you take the number, you take the whole number, you do an AND. F0 means whatever you have here, this always get 0. Because you do a bitwise AND. You keep it, you keep the upper 4 bits because you end with F. F means 1, 1, 1, 1. Yes?
Why do we need to do this? Because it's already zero on the right side, right?
Now we finish, now we explain this. Okay. And then you add val. Val is always lower 4 bits because it's between 0 and 9. Therefore, you do an AND. And since this is 0, this is not 0, you do or you do plus, will be given the same thing. Because this is always 0. That is always 0. So you do bitwise AND, I'm sorry, bitwise OR, and addition, they will give you the same thing. So then you get the correct. This gets here, this gets here, and this gets here. So the question is, why do we need to do this? Because when this corresponds to the delete. Because delete we don't clean up. So this way will clean up. If you add insert and delete, you have something here. So that will just throw it away.
When we dictated 4 bits to the left, don't those values get 0?
Yes, but later on if you look at delete, so we have to look at the delete function. Delete function only decrement used, does not clean up that 4 bits. So you have to do it somewhere. We're doing it here. The question is, why do we need to clean up the lower 4 bits? Because if you look at the delete function later, we don't clean up there. So there's something we inserted earlier, and now we clean it up and we do insert again. So the answer is C. Then we increment used, right? After we add 1 more digit, we increment used. So if you look at delete, we do not. We simply decrement. We don't clean up. We don't modify. If you look at delete, we don't modify it. That's the reason. Somewhere you have to clean up what you inserted earlier. So let's look at the delete function. Delete function, you have to return the latest inserted value. So that's what it says. Delete and return the last digit in the DAC object. Do not string a data array even if nothing is stored. So if we delete, the space you allocated for data does not shrink to make things easier. Okay? If an object has no value, return -1. So if an object is empty, do nothing, return -1. Why is -1 reasonable? Because the data we store is between 0 and 9. -1 means it's not valid data. Does that make sense? Okay, so -1 means something we don't get the valid data. So if we don't have an object, we return -1, or the object has stored no value, we return -1. So that takes care of the cases. Then with decrement used, oh, I go too far. With decrement used, so the return value has to be between 0 and 9. Now consider a situation where before I call the delete function, let's say I use, we have to worry about is even or odd. If used is 6. Yes?
Can you switch to the document camera?
Oh, sure. If used is 6, before we come to the delete function, okay, before calling delete. Now, what is the index? This index 0, 1, and 2, and 3. Which index should we use? 6 means what? 1, 2, 3, 4, 5, 6, 7, 8. If I want to return the last digit I insert, which one should I put? A, B, C, D, E, F, G, H. Which one should I return? F, because that corresponds to the 6. Right? So if you use the 6 before you delete, which index should I use? Do you understand the question? So the index is 2. Do you agree with me? Do you understand what I'm doing? Not quite? I want to return the last number I inserted, the last digit I inserted. How do I know which is the last? Because used remembers what's the last I used. Right? If used is 6, means I have inserted 6 numbers. If used is 6, which A, B, C, D, E, F, G, H, which one should I return? F, right? And F corresponds to index 2. Therefore, I decrement use first. Now use becomes 5. Use becomes 5. And use divided by 2 will give you 5 divided by 2 will give you index 2. So I get the correct index. Then I need to take the lower 4 bits. Right? The lower 4 bits. Therefore, first I know from the index, I know D and E are wrong because the index are wrong. I also know I need to take the lower 4 bits. How do I get lower 4 bits? So among A, B, C, how do I get lower 4 bits? So I mask the upper 4 bits. Right? Does that make sense? So the answer is What's the answer?
D.
D?
Oh no, sorry, B.
B. Why is D wrong?
Because it's not used over 2.
Because the index is wrong.
Yeah.
This index is wrong. Yes?
Yeah, why use C, like just shift it to left? Or A, shift it to the right?
Okay, which 4 bits do I want? If use
The lower ones?
actually now actually there's a trick here, sorry about that. We already decrement. So now use becomes 5. Okay, use becomes 5. So first we get, actually that's still right. We get the correct index. Now we want to use what, lower 4 bits or upper 4 bits?
Lower.
Lower 4 bits. Among A, B, C, which one does that give us lower 4 bits?
A and B.
What does A give you?
Shifts it to right.
And that gives you
The lower bits.
the upper 4 bits. You shift right means you store away the lower 4 bits, you keep the upper 4 bits and move right. Shift right means the following. Okay, so if you have a byte, if you shift right, means it goes here and you put 0 here. That's what shift right means. So A is not correct. Actually, let me hold on. Now use is, yeah, so it
But I don't get it, so you want it to be in that spot?
We want to leave, so that would save it.
use, hold on. If use is now use becomes add. Actually, let's answer number 7 first. Because earlier use is even number, now use is odd since we already decrement. So let's answer number 7 first. So number 7 should be B. Do you agree? Because we already decrement use, so now use is an odd number. We decrement use in line 184. So now use is an odd number. So when I use the example, use is 6. Now use becomes 5 because we decrement already. So number 7 should be B. Do you agree?
Well, I don't think I understand the difference between OX, and errors.
Okay, so the question is the following. What is the difference between, let's say you have a number. The number, if you do shift right by 4, what does that mean? That means you take this, move here, shift right, and add 4 zeros here. Okay? If a number here, and you do AND 0F. Let me do F0 first. That means you keep and you put 0 here. So are they the same thing? If you do bitwise AND, that means this is 0, 1, 1, 1, 1. So that means this goes here and this gets 0, 0, 0, 0.
So the top one is like, so is shift right 4 or not 1, 1, 1 in the lower part?
The lower part depends on what you have here. Shift right 4. So if you have a 1, 1, 0, 1, it becomes 1, 1, 0, 1 here. You just shift. And here, if you have 1, 1, 0, 1, you keep 1, 1, 0, 1. It doesn't matter what it is, since you have 0, it always becomes 0. Does that make sense? Okay. So for question number 7, the answer is B. Question number 6. Question number 6, the answer is A, because now use has changed from odd or even. I think this question may be a little bit confusing. Maybe I should put this before 184. I should swap the order between 184 and okay. Maybe that's the reason it's confusing.
So 6 is A?
6 should be A. Is that what you got? Is that what you have?
So that would make the first digit empty and then keep the second digit?
You don't change. You don't change the array. You only take it out and shift. You are not modifying the array. You are only reading it. Does that make sense to you?
I thought delete was supposed to delete the last digit.
Yes, but I already decremented. So let's go back here. Let's go back here. Let's go back here. If use before calling the function 6 is an even number, but the program decremented first, so it becomes an even number. Sorry. If use is an even number before calling the delete function, since I decremented, it becomes an R. Therefore, it goes to question number 7. Right? It becomes question number 7. Are you with me? Okay, so now consider this next scenario is used. Let's say used is 5 before calling delete. So which one do I want to use? Is 5 means it's going to be this one. And the index is, so I decrement first at line 184. So now used is 4. And used divided by 2 is 2. So I still use correct index. Since I decremented in line 184. So now use is an even number now. In an if condition, question number 6, you have to use the upper 4 bits. Therefore, the answer is A. Does that make sense? You see that? You see that?
So
Okay.
for question 6, it would shift that shaded part to the right?
Yes, you will shift this to the right because as I explained, the operations. I think we're running out of time. Tomorrow I have no office hour because I need to teach the other section because Professor Enquist is attending a meeting. So, and I assume today's exam, I assume nobody needs office hour tomorrow. But if you do need help, you can post your question in Blackboard.